This question where we have a subnetting scenario, a subnetting question. Hopefully this will be the best YouTube video on the entire YouTube that will provide you with a concrete method, a concrete mathematical method to this question. Now let's get started where we have in this particular example we have a subnet. So this is special one where we have a subnet having 64 customers, where 64 customers, each customer has several addresses. So how do you deal with such scenario? So let's start firstly by drawing out the IPv4, the address IPv4 that has been provided. So the address space, well, I'll be presenting this with a block of addresses. So with a large block, and this block starts with 190.100.0.0/16. Now within this big subnet, within this big address space, we have group 1. So we have group 1. This is group 1. Within group 1, how many customers do we have? We have within group 1, we have 64 customers. So let's draw 64 customers. So this is 64 customers. And for each customer, so inside each customer, or let's say inside each subnet, because each customer would need his own subnet. And so within each subnet, we're going to be having 256 addresses. And then let's continue. We do have the second group, where with the second group we have 1 to 8 customers. 1, 2, 3 customers. For each customer we need 1 to 8 addresses. For the third group, which is your last group, we need 1 to 8 customers. For each customer we need 64 addresses, and they are in total 1 to 8 customers. Now it is important to mention that the number of addresses for each subnet should be to a power of 2. Now where do we start from? So at which level do we start? Always when you are faced with such scenario where you have a subnet which contains another subnet which then contains a group of addresses, you'd be starting at the lowest level of addresses. So where is the lowest level of addresses? The lowest level of addresses is here, where we have the group of addresses. We're not going to be starting with the subnet level, however we start with the lowest level, deepest level, where we have the addresses present. So addresses are present inside the subnet. That's where we start from. Now your IP addresses must be a power of 2. So let's check. Is 256 a power of 2? 2 to the power of 8 is equal to 256. So the number of addresses remains the same, unchanged. And so therefore we need 8 bits to present 256 addresses. And so if we do 32 minus the host bits is going to be equal to 24. Therefore, for group 1, the subnet mask will be of /24. Let's do the second group. Now, is 1 to 8 a power of 2? Yes, because 2 to the power of 7 is equal to 1 to 8. And so 7 bits are needed for 1 to 8 addresses. Hence what we do is 32 minus 7 is going to be equal to 25. Therefore the subnet mask of group 2 is going to be 25. Now let's do at group 3. So your third group, 2 to the power of 6 is equal to 64. Now 2 again, 32 minus 6 is equal to 26. So we'll have group 3 as 26. Now with which group do we start? You would always be starting with the group with the largest number of addresses. Which group has the largest number? Okay, the group with the largest number of addresses would be having the smallest subnet mask. You would be starting with the group with the smallest subnet mask because the group with the smallest subnet mask has the greatest number of addresses. We can then now continue and then start by group with group 1. So with group 1 we need customer 1. So customer 1, however, in computer terms it is customer 0. Then we will need first address for customer 1 and then last address for customer 1. So first address of subnet 1 or customer 1, last address of subnet 1. Remember that IP addresses are always contiguous. They're one after another. So the first address in here is going to be 190.100.0.0 of subnet mask is 24. So need 24. How many addresses for each customer? For each customer it is 256 addresses, and so 190.100.0.255. Why 255? Because not 256, because 0th address plus the 256th address, in total this is 256 addresses. That is 0 based numbering with 2 slash. Now we have customer 2. For customer 2, first address, well, it is not necessary in your exam to have customer 2. It's just go and jump to customer 64. It's not necessary to put customer 2. However, for explanation purposes, I need to demonstrate customer 2. So for customer 2, what is the first address? It is going to be 190.100.0. So IP addresses are contiguous, therefore the address after this is going to be in here. So this will be 1 and 0. Remember that your IP address is of 4 octets and each octet must be maximum 255. You can't have 256. If you for some reason get to 5256, this is not possible. You need to increment the octet next to it in order for you to have 256. So again, the maximum number x can be is 255. If a question in your exam comes and asks, maybe you have an address of 100 and then 200 and then 16, then 258, is this a valid IP address? It's not a valid 258. This is not a valid IP address. For an IP address to be valid, it must be maximum on each octet 255. Hope this made sense. We continue. So this will be of subnet mask 24. Last address would be 190.100.1.255. Now let's go to customer 64. So for customer 64, his first address would be 190.100. So alright. What is the number after this? So what is the number after this? There is here a quick method. So for customer 1, notice that it is 0. For customer 2, notice the pattern that it is 1. So customer 2 in computer terms is number 1, customer 1, therefore customer 1. Now customer 64 in computer terms will be 63. Therefore 63 would be your first address of customer 4, 0.0.24. His last address would follow the same pattern where it is 63.255/24. 100 of course, 0.190. Now this was here for your group 1. Now what about group 2? This is here the overall picture of group 1. What about now group 2? Now in group 2, this is group 2, this is where the complexity starts. So before we dive into any explanation of group 2, we need to understand the three compartments of your IPv4 address. Remember that your IP, want you to recall that your IP address is of three parts, three compartments. The first compartment is for the network bits. The second part is of your subnet identifier bits, and then your third part is for your host bits. We know all of this is 32 bits, and because this entire thing is 32 bits, subnet mask is equal to the network bits plus the subnet identifier bits. Why do we have subnet identifier bits? These subnet identifier bits will be different for each customer. So the subnet identifier bits will be different for customer 1, will be different for customer 2. That is how we differentiate. However, they all have, they share in common the subnet network bits. They don't have, they share in common the network bits. They don't have the same subnet identifier bits. Every time the subnet identifier increments by 1 from one customer to another. This would make sense in just a bit. So again, the subnet mask is subnet bits plus the network bits plus the subnet net bits identifier, and this is your subnet mask. So before now this was a big picture of your IPv4 addresses. Now we can go into group 2, start solving group 2, customer 1, where in computer terms he is 0 actually. So we start with the first address. So first address of customer 1, remember they are always contiguous, so they are always contiguous, so the address of the last customer within the first group, after it will be the first address for customer 1 in the second group. So what was the last address? The last address is 190.100.63.255. Therefore, the next address for customer 1 would be 190.100.64.0 with the subnet mask of 25. Now this is the first address. What about the last address? Now remember, with the last address, it's going to be incremented by 0.100.64.127/25. Why 127? Because 0 plus 127 is equal 128, where for each customer we needed 128 addresses. Now what about customer 2? Customer 2 is first address will be the one next to this, 190.100.64.128/25. Now as you can see, now we're starting to approach a complex 255, because 128 plus 127, each time you are going to be incrementing 127, will be equal to 255/25. What will happen next for customer 3? Again, you are not required to show customer 3 in your exam. However, I'm showing for explanation purposes. Be 100.65.255. 0/25. Now you need to keep going on until you reach customer 128, and we're not going, this would be an overhead to keep doing and repeating for each customer. So we need a shortcut to jump to 128 customer. So what is the shortcut? So the shortcut is to play with the subnet bits. This is your shortcut that will allow you to go to your to jump subnets. So we need to jump to a subnet of 1 to 8. So how do we do this? So we're going to be finding the subnet bits of the 28th customer, or in other words, you're going to be finding the subnet bits for the subnet 1 to 8. A customer is a subnet actually. So what is the first address for the customer 1 to 8? And what is his last address? Remember, recall that your IP address is the 3 parts: network, subnet, and host. So what are the network bits? So the network bits within the question has been given to be 16. So 16 would be your network bits. So you'd say 16. Now, how many bits have been reserved for the host? The number of bits for the host is 7. How did we do 7? Because 32 minus the subnet mask 25 would be equal to 7. Now what about the network bits? How many bits for the what about the subnet bits? These subnet bits. We know this is 32. So do the math and you'd be getting 9. Network, subnet, and then we have the host bits. For customer 1, okay. Now, because now we know that 9 bits are reserved for the subnet identifier, you need to manipulate and play with the 9 bits in order for you to jump to the 1 to 8 subnet. So how do you do this? You'll go to the first subnet. Always, when you are playing or manipulating subnet bits, you would start with subnet 0. That is your start of point. Your starting point will be subnet 0 first address. This will be your golden address where you would be starting. So we need 9 bits. So for customer 1, where he's actually customer 0, first address is 190.100.64.0/25. We know that 16 bits are reserved for the subnet. First 16 bits are reserved for the subnet. This is 8 bits, this is 8 bits. And so we know that we need 9 and 7 bits are reserved for the so 9 for the subnet identifier, 7 for the host. So what we need to do is convert this to binary. So 190.100 convert 64 to binary. So 64 in binary would be equal to 01 0 0 0 0 0 0. And then what we'll have, 0 is then all zeros. So 0 1 0.000 0 0 0 0 0. 9 bits, or let's keep this. We know 9 bits are reserved for the subnet. So 1 2 3 4 5 6 7 8 9. So these are in total 9 bits for the subnet. These 7 bits are for the host. So start with this. Now we know these 9 bits are reserved for the subnet. Because they are reserved for the subnet, get the 9 bits. So write them down. 0 1 This is a number of 9 bits. Convert this number of 9 bits. Convert this number of 9 bits into decimal. So if you convert this number of 9 bits, into decimals, you get 1 to 8. So your starting point would be 1 to 8. So 9 bits are presenting 1 to 8 as a number. So 1 to 8, then add the number of subnets. Number of subnets I want to be reaching to is 127. So I'll be adding 127, and in total I get 255. What do I then do? I convert 255 back to binary. And because it is binary, so it will be 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. However, inside we can't put 8 bits. We need to replace in 9 bits. So what do? We would be adding an additional 0, because 0 at the left to make it 9 bits. Now put this number of 9 bits back inside here. So 190.100. So this number is 9 bits, so I'll be splitting this, getting 8 bits in here. So it's a 0, 1, 2, 3, 4, 5, 6, 7.1. This would be. So what I've done is that I put this number in place of this number to get this. Now convert this. What do we then get? Now convert this number to decimal. So if you convert this number to decimal, 127.100.190, convert this number to decimal, would be 128. So 128. And this would be the first address. This would be the first address of customer 128. And what would be the last address of customer 128? 190.100.127. Now add 127, you get 255. Don't forget your subnet mask, 255.255. Now this was group 2. Let's summarize quickly. So, many people do lose track at this step, but it is simple. You identify the network bits. Because you want to jump to the 128 subnet, you need to identify and manipulate the subnet bits. Now, you're going to then convert the subnet bits to binary. Find your subnet bits, convert them to binary, convert your bits to decimals, your subnet bits to decimal. After getting the subnet bits into decimals, you'd be adding the number of subnets, which is 127 in this case. So 127, we want to jump to the 127 subnet. So 127, you get 255. 255, convert it back, so it's as if a loop going to from binary to decimal, from binary to decimal, from decimal back to binary. You get 8 ones, and so because 8 ones is not 9 bits, so you can add a 0 at the end to make it 9 bits, and replace this number into here, into this place of your subnet bits. And then you will be replacing it. As you replace it, remember that it must match 8 bits, so you would partition sometimes you would need to partition, sometimes it's not necessary to partition. In this particular scenario, we need to partition because it is 9 bits. So you'd replace them inside in here to get this number. Now this will be your first address, and this would be your last address. 127, convert this number to decimal, you get 127, convert this number to decimal, you get 128, and then this would be finished for group 2, sorry. Now I know this may be long, however, if you follow these steps, we'll be repeating the same thing for group 3. So to put more emphasis on understanding and practice on what is going on, the big picture. So let's start group 3. Group 3 first address would be 128.0 with the subnet mask of 26. Now what about, so this is customer 1. And how many customers do we have? We have, again, 128 customers, 190.100.128.63/26. Now let's go for customer 2. Now, it's not necessary for you to have customer 2. I'm just doing this as a rough work for you to get the... You can have customer 2 within your exam paper. It's not necessary to put customer 2. You can immediately jump to customer 1 to 8. Again, I'm doing this for I'm doing this to show the pattern of the addresses. 128.64/26. Last address would be 190.100.128.127. Why 127? 64 plus 63 would equal to 127/26. Now let's jump to 128 subnet. When we jump addresses, no, instantly we need to manipulate subnet bits identifier. And so you would partition your IP address into 3. 1, 2, 3, 16 bits for the network. For the host, how many bits do we have? So 32 minus the subnet mask would be equal to 6. And so you'd have 6 for the host. What would the subnet identifier? Do the math. This is all 32. And you get 10 for the subnet. In this case, we do have 10 bits for the subnet. When we are now manipulating subnet bits, your starting point would be your key starting point would be the first subnet. The first subnet is customer 1 in this case. Customer 1 first address is 190.100.128.0. Now these are reserved for the network. Convert the rest to binary. So if you convert the rest to binary, you would be getting 190.100.12. Let's maybe have this 1, 2, 3, 4, 5, 6, 7, 8. Now convert the zeros, the rest of the zeros. So 1 to 8 to binary, this is the number. Now the zeros convert, so 1, 2, 3, 4, 5, 6, 7, 8. We can then, so 10 bits for the subnet bits identifier. These are the 10 bits. Convert these bits to binary. So to identify your starting point, so converting this 10 bits, so you can do 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. In this case, this number is 10 bits. So if you convert it to decimals, you get 512. Now 512, how many subnets do we need to jump? We need to jump 127 subnets. So plus 127 subnets would be equal to 639. 639 is your new subnet identifier, your new subnet ID. Subnet ID for the first subnet was 512. So I want to jump 128 subnets, 127 subnets. So 136 will be the subnet ID for the 128 subnet. Convert the subnet ID to binary. So you would get, because this is a massive number, expect getting 10 bits. So if you do convert this to binary, you would be getting 100 and then 111 1111. This is 10 bits, so you partition it to 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Partition this to 8 bits. What do we then do? We replace the new subnet ID inside here. This subnet ID, replace it in here to get the new subnet ID. Subnet ID will be 190.100.111.11.11.000000. Simple now. Convert this to binary, convert this to decimal, you get 190,159. Convert this number to decimal, you get 192, and then put in your rest, so /26. This will be the first address. Last address would be 190.100.159 point, so 192 plus 12 plus 63 would be 255/26. And this was for customer 128. And this was all. Again, let's summarize. So you would identify the number of bits of the subnet. Then after getting the number of bits for the subnet, you would find the subnet ID plus the number of subnets you want to jump, and then you'd get the new subnet ID, convert the new subnet ID to binary, and replace it inside the subnet bits identifier, convert them, partition them into 8 bits, convert your 8 bits into decimal, and you'd be getting this address. I hope this was helpful. I hope this explanation was simplified, not overwhelming. Repeat the video, practice on your own, several questions, and I hope you can succeed in all your exams. Thank you.